section, we show how the huge address space of IPv6 prevent address depletion in the future. We also discuss how the new addressing responds to some problems in the IPv4 addressing mechanism. An IPv6 address is 128 bits or 16 bytes octets long, 4 times the address length in IPv4. A computer normally stores the address in binary, but it is clear that 128 bits cannot easily be handled by humans. Several notations have been proposed to represent IPv6 address when they are handled by humans. The following shows two of these notations, binary and hexadecimal. The address space of IPv6 contains 2 to the power of 128 addresses. This address space is 2 to the power of 96 times the IPv4 address. Definitely no address depletion. As shown, the size of the space is 340, 282, 366, 920, 938, 463, 374, 607, 431, 768, 211, 456. Like the address space of IPv4, the address space of IPv6 is divided into several blocks of varying size, and each block is allocated for a special purpose. Most of the blocks are still unassigned and have been set aside for future use. Table 22.1 shows only the assigned blocks. In this table, the last column shows the fraction each block occupies in the whole address space. Prefix for assigned IPv6 addresses. Global unicase address.
IPv6 is intended to replace IPv4. IPv6 addresses the main problem of IPv4, which is the exhaustion of addresses to connect a computer or a host in a packet switch network. IPv6 has a very large space and consists of 128 bits compared to 32 bits in IPv4. The base header occupies 40 bytes, whereas the payload can be up to 65,535 bytes of information. Each packet is composed of a base header followed by the payload. To make it simple, IPv6 increased address space, provide more sufficient routing, reduces management requirement, has better mobility support, and provides security.
Now, let's move to the ICMPv6 protocol. What is the ICMPv6 protocol? It is a protocol that modified in TCP/IP, and it's also follow the same strategy and purpose like version 4, but it is more complicated because there is some protocols that are independent, and this version also added some new messages, so it is more bigger than the version 4. In this protocol, it has many kinds of messages such as error messages, informatical messages, neighbor discovery messages, and membership group messages. Now, let's move one by one to the messages in ICMPv6 protocol. First is error messages. Error messages is responsible to report error such as destination, packet too big, unreachable, time exceeded, and parameter problems. In version 4, error messages is used to control congestion, but in version 6, it used to take care congestion. Second is informatical messages. These messages has two categories, which is echo requests and echo reply requests. These messages is aimed to check whether two devices in the internet can communicate with each other. To make you more understand about these messages is like this. A host or router can send echo request messages to a device, and the device can reply the messages using echo reply request to a host or a router.
Peralihan dari internet protokol versi 4 ke internet protokol versi 6. Pada zaman ini, kita mempunyai internet protokol versi baharu. Peralihan internet protokol ini mesti berjalan dengan lancar untuk mengelakkan sebarang masalah antara sesuatu internet protokol versi 4 dan internet protokol versi 6. Dalam peralihan internet ini mempunyai 3 strategi yang telah dirancang. Pertama, dual stack. Ia menjalankan kedua-dua internet protokol versi 4 dan internet protokol versi 6 pada satu peranti yang sama. Yang kedua, tunneling. Internet protokol versi 6 akan melalui rangkaian internet protokol versi 4. Yang ketiga, header translation.